Hello everybody, it's Dumplet here. Here's an item on probability. Alice is at the origin 0, 0 of the coordinate plane. She moves according to the roll of a standard cubical die. If the die shows a 1, she moves 1 space to the right. If the die shows a 2 or 3, she moves 1 space to the left. If the die shows a 4, 5, or 6, she moves 1 space up. What is the probability that after 4 moves, Alice lands on the point 1, 1 for the first time? As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now here's a figure on the right for reference, and we can try to count the number of ways that Alice can move from 0, 0 to 1, 1. In fact, we're going to implement similar techniques as the trick shown in the two previous videos on binomial distribution. So let's try to do that, and we have this. So we have 3 possible moves, left, right, or left, up, and right. Now let's denote them as blue, green, and red respectively. So let's take a look at the figure. From 0, 0 to 1, 1, there is a net change of 1 in the vertical side, so there's a net change of 1 unit up, and there's a net change of 1 unit to the right. Now since only the up here concerns the vertical change, and there must be a net change of 1 up, the number of ups that Alice must take, or Alice should take, to reach 1, 1 is obviously 1. If it's less than 1 or greater than 1, then Alice would never reach 1, 1. Now for the horizontal displacement, since Alice would have a net horizontal change of 1 unit to the right, well, since we need 4 moves in total, so since 1 is already given to the up, there's 3, so the distribution must be 1 and then 2. So 1 unit to the left and 2 units to the right. That would give a net horizontal displacement of 1 unit to the right. So now, similar technique, we're going to take the number of permutations of 1 left, 1 up, and then 2 rights. So permutations will tell us that 4 factorial and then divided by the repeated element. So there are 2 red arrows, so we divide it by 2 factorial. Now 4 factorial is 24, 2 factorial is 2, so this will give us an answer of 12. But don't get too excited yet, because we have to remove something from 12 because of the condition that Alice lands on the point 1, 1 for the first time. Now the 12 here is just all the possible arrangements of these 4 arrows. However, this would include cases such as up, right, right, left. So just an example. But in the first 2 moves, up and then right, Alice will already hit 1, 1. So cases like these should be removed. So let's try to consider what are the cases that will result in Alice reaching 1, 1 before 4 moves are used. In fact, it's these. So 1 up and then 1 right would obviously result in Alice hitting 1, 1 in just 2 moves. And we can easily just take the permutation of them, 2 factorial. So it doesn't matter if it's right, sorry, up, right, or right, up. If these are the first 2 moves, then Alice would hit 1, 1 before 4 moves. So it must be paired with obviously 1 left and 1 right, since we're using 1 left, 1 up, and then 2 rights in total. So again, we can still permute them, 2 factorial. So in total, there will be 2 factorial times 2 factorial, which equals 4. So 2 times 2, which gives 4. There are 4 ways for Alice to end up at 1, 1, but Alice would hit 1, 1 in the first 2 moves. Now, since there are 12 in total and there are 4 cases that you want to remove, the total number of ways for Alice to reach 0, 0 to 1, 1 without passing 1, 1 in the first few moves is 12 minus 4, and that gives us 8. So this is the only, I say, difficult part to this item, because after we get the number of arrangements for these 4, or the 4 arrows, the rest is just the same. The rest is just converting these 4 arrows into the respective probabilities. Now, how did I get these probabilities? Let's go back. Now, if the die shows a 1, she moves 1 space to the right. So the red arrow, the red right arrow, it's the probability when it happens when the die shows a 1. So it's 1 over 6, since there's only one digit that corresponds to Alice moving right. Now for the up arrow, let's consider the left arrow. The left arrow will happen if the die show a 2 or 3, so it's 2 over 6, and this will be equal to 1/3. Now finally, for the up arrow will happen if the die shows a 4, 5, or 6, so that's 3 over 6. 3 over 6 gives 1/2, and that's the 3 numbers you see here. So green is 1/2, blue is 1/3, and then red is 1/6. So similarly to what we do in the binomial distribution, we write the number of ways to arrange these items. So we know that there are 8. So 8 is the number of arrangements, so 12 minus 4. And then we write each of the probabilities. So for the blue, there's a 1/3. So let's write a blue 1/3 over here. And then for the green arrow, there's 1. And it has a probability of 1/2 happening. So let's multiply it by a green 1/2. Now last, for the 1/6, there are 2 arrows. So we have the 2 red 1/6. So 1/6 squared. So this is the thing that we want to evaluate, and this will result in the probability. So let's try to expand this. So it's going to be 8 times 1/3 times 1/2 times 1/6. Now we can simplify things here. The 8 and the 2 will cancel, leaving us 4. 1/6 is also 1 over 36. And 4 and the 36 here would cancel, giving us 9 in the denominator. So it's going to be 1/3 times 1/9, and it will give us the answer of 1 over 27. And this will be our final answer. So in items like these, where technically you're arranging stuff, it may be the number of flips of a coin, the number of roll of a die, or in this case, the number of arrows that you want to permute. So any other items that are similar to these, you can use the technique that I've shown you in the binomial distribution video. Hope you guys learned something new in this video, and I'll see you in the next one. Bye bye.